Okay, yeah, as I was saying, notice that you have two sides. You want to find one of the sides, and you have two angles. So this is a sine, to use the sine rule. Okay, okay, this is how you match up your sides, yeah, and your angles. So this angle is facing this side, and this angle is facing this side. So when you write your fraction, the pairs you write in one fraction. For example, x over sine 38. Okay, once again, you see, I want to find the side, right? So I put my side on top. If I want to find an angle, I put my sine on top. Okay, so x over sine 38 is 8 over sine 56. Okay, then this is just simple fractions, right? So I just multiply sine 38 on both sides. So x is 8 over sine 56 times sine 38. Okay, you can skip this step if you're confident. Just key this in your calculator. Get 5.94. Okay, another example. Same thing. See this x is facing 40 degrees. 12 is facing 105 degrees. So you form your equation, x over sine 40 equals 12 over sine 105. Get 7.99. Okay, the sine rule actually comes from the sine rule that we use for the area of triangle. So recall that the area of triangle, okay, I can calculate this by doing half AB sine theta. Again, like AB is just two sides, sandwiched between them is an angle. Okay, so I'm going to consider a just a random triangle. So this is A, B, C. Okay, I'm going to call this A, B, C. Okay, then this will be angle A, this will be angle C, this will be angle B. Okay, you should know. Okay, first I'm gonna take this angle first, angle A. Okay, so the area of my triangle will be half BC sine A. Agree? Can I? Okay, then I change my perspective a bit. Okay, now I take this one. If I refer to angle C, my area will be half AB sine C. Finally, I can also take, I can refer to this angle B here, half AC sine B. Now notice, because this is the same triangle, the area must be the same. So all of these expressions are equal. Okay, then just a series of manipulation. First, I just multiply 2 throughout. So I just cancel out the half. And then I divide ABC. Okay, from the first expression, I'm going to get sine A over A, sine C over C, sine B over B. That's where the formula comes from. So you might think, wait, how did we conjure up this new formula? Where does it come from? It literally comes from a fact that you all learned previously. And then think about it. How did we get this? How did we get this formula up? Right, we simply use half base times height and basic trigo. So you see how mathematics get harder and how you learn new stuff. We just take like two things, okay, and then we combine to learn something new. Okay, and then later on you might learn, you will learn something else. Then we combine this again, and then we generate something new. Right, so this is how new mathematical concepts and formulas are actually formed in real life as well. Right, we just take two simple ideas, put them together, and then we create something new. Okay, we have a word for this. This is called innovation. Yeah, so maths is also an innovative enterprise. Oh, also, the very, very first lesson when I introduced you trigo, notice where, do you recall where trigonometry comes from? It comes from the idea of similar shapes. Okay, I'll give you a while to digest this. Let me know when you're ready to move on. Okay. So just quick recap. A sign or a hint for you to use sine rule is you have two sides and two angles. Okay. Now, the hint for you guys to use cosine rule is when you have three sides and one angle. So for instance, if you take a look at I and J, okay, you are given three sides, 1, 2, 3, and an angle. 1, 2, 3, and an angle. So it's the sum. It's a sign for you to. It's a sign for you. It's a sign for you to use the cosine rule. Okay, what is the cosine rule? Cosine rule, it looks like this: c squared equals a squared plus b squared minus 2ab cosine big C. Okay, you can sort of see a bit of Pythagoras here. Because we to derive this, we kind of need to use something called a Pythagorean identity. Okay, just FYI, the Pythagorean identity is this one: sine squared theta plus cosine squared theta equals 1. Okay, this one you don't need to know unless you're doing MF. Okay, and I'll show you how to use the formula. But basically, you all need to. You actually don't need to memorize this. This will be in your formula sheet. But if you do a lot, you naturally memorize this already. Okay, so let me get out. Okay, so to use the cosine rule, you have to first identify the angle and the side opposite to that angle. So this is my angle, 125, opposite is x, right? So this is my C. You can think of it that way. Okay, so my equation will look like this: x squared equals 11 squared plus 14 squared minus 2 times 11 times 14 cosine 125 degrees. Okay, really you just key this whole string into your calculator and you're done already. X is 22.2. Okay, remember to square root. Okay, all done?
Yeah.
Yeah. Okay. Now, what happens if, let's say, they want you to find the angle, for example, part L? Same thing, we form our equation first. Now, theta is facing 5. So this will be your C squared. Okay, so your equation should be 5 squared equals 8 squared plus 12 squared minus 2 times 8 times 12 cosine theta. Now, just be careful when you're manipulating this because in the past, a lot of students will make mistakes here. So these are sums. This is a product. So I'll tell you what the common mistake students will do first. Right, they'll tell me, okay, 5 square minus 8 square minus 12 square plus 2, 8 times 12. Then say, okay, this is cosine theta. Then they key this into a calculator and then they let me, teacher, math error. Okay, so be careful of this mistake. Okay. Now, the proper way of doing this is if you move your 8 square and 12 square to the other side, yes, it is subtract. It becomes subtraction. So 5 square minus 8 square minus 12 square. Okay, then this is a product. So when you move it to the other side, you need to divide. So this is divide. -2, 8, 12. Okay?
Oh, okay.
This whole string in your calculator, you get theta equals 17.6. Let me go through this. Okay, for example, in part O, okay, I want to find x, I want to find y. So to find x, I pay attention to this triangle here. Okay. I am given two sides. I have one angle here. Okay, I can actually figure this angle out. This is 100 degrees. So I have two angles and two sides. This is a hint that I need to use the sine rule. Okay, so to find x, I need to use the sine rule. So x over sine 100 equals 10 over sine 52. Okay, so x is just Sine 52 times sine 100, 12.5. Okay, next, to find y, I turn my attention to the other triangle here. Okay, and I go and observe first, right? I have 1, 2, 3 sides and an angle given. So that's a hint that I should use the cosine rule. Okay, and y is facing 80 degrees, so that will be my c squared. So y squared equals 10 squared plus 16 squared minus 2 times 10 times 16 cosine 80. Okay, one more reminder to write this out. Okay, after that, you can key in the whole string of stuff in your calculator and solve for y. But this line need to write out. 16 squared minus 2 times 10 times 16 cosine 80 squared. Okay, 17.3. Easy as that. Okay, 87 says in the diagram, AC is 40, CD is 32, blah, 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 blah. Okay, find the length of AB. Okay, I'm going to observe first this triangle here where AB is. Okay, same things here. I'm given 3 sides, 1, 2. This one I need to find, and I'm given an angle. So straight away, I know to use the cosine rule. This is how I pick up patterns. Okay, so the cosine rule, AB squared equals 40 squared plus 27 squared minus 2 times 40 times 27 cosine 110 degrees. Like I said, if this comes out in IG, it's 3-4 marks already. Just like that. 40 squared plus 27 squared minus 2 times 40 times 27 cosine 110 square root. Okay, 55.4. Okay, then I turn my attention, AD. So I turn my attention to this triangle here. You realize it's the same thing. Okay, I have 3 sides. I got 40, I got 32. I want to find this angle. Okay, I have this, sorry, I want to find this side and I have this angle, this 80 degrees. So use the cosine rule again. Okay, so AD squared is 40 squared plus 32 squared minus 2 times 40 times 32 cosine 80.
Isn't it 70? Yes.
Oh, yeah, it is 70. My bad. 70. That's 40 times 32 cosine 70 square root. So 41.8. Area of triangle ABD. I see the word keyword area. So there are 2 ways to figure out the area of triangle. The direct way, one is use half base times height. The other one is use your sine rule. Okay, ABD is this entire triangle here. Okay, damn. Okay, I have this 55.4. I have this to be 41. you guys don't learn Heron's theorem. The Heron's theorem you can actually find. Anyway, realize that okay, if I look at the triangle like that straight away, I would need one of these angles. Right? And you can actually go and figure out any of these angles using the sine rule or using the cosine rule. Okay. Okay, so first method, let's say you anyhow just pick. You want to find this angle. So you can use sine rule to find this angle. So sine angle ABC over 40 equals sine 110 over, this is 55.4. Okay, then angle ABC is do something wrong. Sine 110 divide 55.4 times 40. Sine inverse. Okay, 42.7 degrees. Okay, then you use the sine rule. So area is half times this whole thing. This will be 59 times 55.4 sine 42.7 degrees. We get 1110. to 3SF. Okay, this is one method. It's actually not too difficult to do this method, but there's another method. I think this is slightly faster. Is that you actually calculate the area of the triangles separately and you add them up. So you observe this triangle here. You observe this triangle here. Okay, this is slightly faster because you already have the angles that you need to figure out the areas of each of this triangle. Okay, so a faster way to do this, it's actually not much faster. Okay, but the area is half times 27 times 40 sine 110. This is the yellow color one. Okay, plus half times 40 times 32 sine 80. This is the green color one. Okay, actually, it is much faster. So you just key this whole string into your calculator, you will get the same answer. 1110 cm squared. Okay, so two methods, both works. Okay. Any questions? If you haven't copied, don't worry, I'll give you time to copy later, but try to follow me first. Can I? Okay. Lastly, the shortest distance from A to BD. I think we've done this last lesson, right? Shortest distance is the anyone? Shortest distance is also known as the
perpendicular.
Yes, perpendicular distance. So finding the perpendicular distance from A to BD, which is the height of the triangle here. So I label this H. Okay, then we work backwards a bit. We already have the area of triangle. So half times base, which is 59, times height, will give us 1110. We just work backwards. So H is 37.6 cm.